Namaste, my name is Rishi. I'm studying in Sri Venkateshwara College of Engineering, ISC. My USN is 1VE23 IS042, third sem. Today's topic we're going to cover is machine instructions and programs. So from the subject DDCO, machine instruction and programs. This presentation explores the fundamental concepts of machine instructions and programs, delving into their structure, representation, and execution within the realm of computing. Introduction. Understanding the fundamentals. Core building blocks, data representation, program execution. These are the fundamentals of the machine programs. Core building blocks. Computers are composed of fundamental components like the central processing unit, CPU, memory, and input-output devices. Understanding their roles is crucial for comprehending how machine instructions work. Data representation. Computers store and manipulate data in a binary format using OS and 1S to represent different values, instructions, and information. Program execution. Machine instructions are executed sequentially by the CPU instruction from memory and performing corresponding tasks. The structure of a computer program. Instructions. Instructions are the fundamental building blocks of a program dictating the actions the computer should perform. Data. Data represents the information the program operates on, including numbers, text, and other types of values. Control flow. Control flow determines the order in which instructions are executed, allowing for branching, looping, and conditional logic. Machine learning language, binary program, instruction and instruction code is 0 1 0 0 0 0 1. Operands are 0 0 0 0 0 10 0 0 0 0 0 1. Instruction Set Architecture ISA registers, addressing modes, and instruction set. It is known as instruction set architecture. In registers are small, fast memory locations within the CPU used to hold temporary data and program execution state. Addressing modes. Addressing modes define how instructions access data in memory, including direct, indirect, and register-based addressing. Instruction set. The instruction set defines the specific operations that a processor can perform, such as arithmetic, logic, and control flow operations. Abstraction layers in computing: hardware, machine language, assembly language, high-level languages, applications. These are the five abstraction layers in computing. From hardware, the physical components of a computer system, including the CPU, memory, and input-output devices. Machine language, the lowest level of programming language directly understood by the processor, consisting of binary instructions. Assembly language, a symbolic representation of machine language using mnemonics to make instructions more readable. High level languages, languages like C, Python, and Java, designed for human readability and ease of program abstraction, allow low level details. Applications, software programs that users interact with built upon layers of abstraction, providing a user friendly interface. High level programming languages. Abstraction and readability. High level languages provide abstractions that simplify programming, allowing developers to focus on problem solving rather than low level details. Human readable syntax. High level languages use syntax closer to natural language, making them easier for programmers to understand and write. Probability. High level languages are often designed to portable, allowing process different hardware platforms with minimal modifications. Compilers and interpreters. Compiler. A Smith code. Have Smith scale machine code. From compilers and interpreters. First one is source code, the program written in a high level language understandable by humans. Compilation. A compiler translates high level language code to machine language, producing a executable file. Interpretation. An interpreter executes high level code line by line without creating an executable file. Machine code, the binary instructions that the processor can default and execute. Decode and execute. Executing machine instructions. Fetch, decode, execute. CPU, fetch. The processor retrieves the next instruction from memory. In CPU, there are parts concatenation, register, mavaction, intersection. Decode. The processor interprets the instruction and breaks it down into its individual components. Execute. CTU, control unit. The processor performs the operation specified by the instructor, register and memory. Optimization techniques. Instruction scheduling, code inlining, loop unrolling. Instruction scheduling, reordering instructions to minimize execution time and improve performance. Code inlining, replacing function calls with the actual function code to reduce overhead. Loop unrolling, expanding loops to reduce loop overhead and improve performance. Thank you. Please do like, share, and subscribe.